This is the second video for solving special cases, and this one's talking about classifying systems of linear equations. So the three different classifications that you're going to be using in this class are independent, dependent, and inconsistent. These classifications are indications of the type and number of solutions that a system will produce. So independent equations are the ones that cross at exactly one point. So this is very specific in the sense that they have different slopes. So when you put them into y equals to mx plus b format, the slopes for each will be completely different. They'll have nothing in common. Dependent means that they end up being the exact same equation, so their slopes are the same and their y-intercepts are the same. Again, your best bet is to rewrite them into slope-intercept form so that you can check out the slope and the y-intercept. Also, dependent is when one system is a multiple of the other. So an example could be x plus y is equal to 3, and then 2x plus 2y is equal to 6. If you take the second equation and divide everything by 2, it's going to give you the first equation. This is an example of a dependent system because they end up being the exact same equation. Inconsistent are lines that are parallel. Parallel lines have the same slope but different y-intercepts. That's what makes them parallel. Also, parallel lines have absolutely no point of intersection, so the answer would be, or the number of solutions would be none. So again, the three words that you need to know are independent, dependent, and inconsistent. You're just going to have to figure out a way to remember them. Dependent, if you think about dependent, one depends on the other, so they're the same. Inconsistent, by definition, means that they're similar but they're not identical. So same slope but different y-intercepts would be an example of something that's inconsistent, while independent means they're completely unrelated. Different slopes would mean that they are completely unrelated. So the example says to classify each of these two systems. So the first one has 2y is equal to x plus 2. Again, your first step is to make these both into slope-intercept form. So I'm going to divide the first one through by 2, and that is going to give us y is equal to a positive 1/2 x plus 1. So for the second one, I need to add 1/2 x to both sides. So that will give us y is equal to 1/2 x plus 1. You'll notice that once I've done that, this new system indicates that these two equations are the same. Actually, they're identical. Therefore, they are going to be dependent because they have the same slope and same y-intercept. So for the second classification, you're going to want to start by solving the first one. So y is equal to 2x minus 2, and then the second one is pre-written for us in slope-intercept form. You'll notice right off the bat that this has a slope of 2, while the second one has a slope of 1, which aren't the same. And when the slopes don't match, you're independent. Okay? An example of inconsistent would be if your slopes are the same, but your y-intercepts are not. From your quiz today, the negative 2x plus 2 and negative 2x minus 2 was an example of one that would be inconsistent because it produced parallel lines and thus no solution. Okay? So for your U-try, you're going to determine of these three if it's independent, dependent, or inconsistent. Sorry. Okay. And I think, yep, that is the end. So again, of the three, which one is independent, dependent, and which one is inconsistent?